we're going to find the line integral f dot dr along the curve C, where f is the vector field 2x plus y I plus 2x minus y j, and C is the triangle bounded by the lines y equals 0, y equals 1 minus 2x, and x equals 0, traversed in an anti-clockwise direction. I'm going to start by looking at what C looks like. So y equals 0 is the x-axis, x equals 0 is the y-axis, and the line y equals 1 minus 2x crosses the x-axis at a half, to be precise at the point a half 0, and the y-axis at the point 0, 1. So C is the triangle which I'm going to outline in blue like this, and I'm putting arrows on to indicate the anti-clockwise direction. Now, what do we mean by the vector field? Well, by the vector field we mean that at each point in the plane there's a vector whose I component is 2x plus y and whose j component is 2x minus y. Let's see what that means for a couple of points. So let's take the point here at a half 0. So at that point the I component would be 2 times a half, which is 1, and the j component would also be 2 times a half, which is 1. So the vector would be I plus j, or 1, 1, if you prefer to think of it like that. What about this point up here at 0, 1? Well, the I component would be 1, and the j component would be minus 1. So that vector is going to look like that, and corresponds to I minus j, or if you prefer it, 1, comma, minus 1. Okay, let's move on now and think about the actual line integral. So we'll come down to the next screen, and I've copied the basic information onto each screen so that we don't have to keep looking back for it. The line integral we're looking at was described as f dot dr. Well, we haven't said what r is at this stage. Well, r is just the vector xi plus yj. So dr we can think of as being dx I plus dy j. And by f dot dr we're looking at a scalar product. So what that means is that we have the integral along C. Now, to take the scalar product, we multiply the two I components together, so we get 2x plus y dx, and we multiply the two j components together and add it on, so that gives us 2x minus y dy. And you'll quite often see a line integral written in that second form. It's just the expansion of the rather succinct vector notation f dot dr. Before we do the actual calculation, let's remind ourselves what this line integral means. Well, if we have a vector field f on the plane, as we've got here, 2x plus yi plus 2x minus yj, then the line integral gives us the value of the work done moving an object along the curve C, in this case around the triangle C. Okay, let's move on now to do the calculation. And because we've got a triangle bounded by 3 lines, we're going to take the calculation in 3 bits, each corresponding to one of the lines. So the first line we'll take is y equals 0. So what we're looking at is along the line y equals 0, the integral 2x plus y dx plus 2x minus y dy. To find the limits of that integration, we need to go back to look at the triangle, and we can see that as we move along the line y equals 0, we're going from x equals 0 to x equals a half. So the limits of the integration are x equals 0 to x equals a half. Back to the calculation. Now the first part of the integral is straightforward. It's integrating with respect to x, and we know that y equals 0. So that first part is just going to give us (2x) dx. What about the second part? Well, here the integral is with respect to y, and we need to change this to be with respect to x. Now, when you change a variable, as in this case from with respect to y and with respect to x, and you've got a function of y in terms of x, then you need to multiply the integrand by dy by dx. So what we need is 2x minus y multiplied by dy by dx, and then that will enable us to integrate with respect to x. In this case, of course, y equals 0, which means that dy by dx is 0, so the whole of this term here is 0. That leaves us with a nice straightforward integral to do. The integral of 2x with respect to x is just x squared, from 0 to a half. Putting in the limits gives us a quarter. So that's the first side of the triangle done. Let's move on. The next side of the triangle is y equals 1 minus 2x. So again, we've got our integral 2x plus y dx plus 2x minus y dy. Let's again go back to our triangle to see what the limits of integration are. Well, we're coming along this line here. So at the beginning of the line we've got x equals a half, and at the end of the line we've got x equals 0. And notice I'm being careful about the direction here. We're going from x equals a half to x equals 0. Let's put in the value of y. So in the first bit we get 2x plus 1 minus 2x, and that's with respect to x. And in the second part we get 2x minus 1 minus 2x, and again we need to multiply that by dy by dx so as to get the integration with respect to x. So let's tidy this up a bit. We've got x equals a half to 0, and the first term, as the two x's will cancel, will just give us 1. And the second term, well, we've got 4x minus 1, and that's going to be multiplied by dy by dx, which in this case is just minus 2. And of course we're integrating all that with respect to x. So tidying up further, we've got 1, and then the minus 1 times the minus 2 gives us plus 2, so altogether that gives us 3. And then the minus 2 times the 4x gives us minus 8x with respect to dx. And I've just got room on this screen to squeeze in the integration. So that will give us 3x minus 4x squared, limits of a half to 0. So we'll get minus 3 halves plus 1, which is minus a half for that part of the triangle. Okay, let's move on now and do the final side of the triangle. So now we're looking at the side x equals 0, and we're doing the integral 2x plus y dx plus 2x minus y dy. What are the limits? Well, if we go back to our sketch of the triangle, we can see that we're coming down the y-axis, and so y is going to be going from 1 to 0. So for this part of the integration, our limits are y equals 1 to y equals 0. So for this part of the integration, we want to integrate with respect to y rather than with respect to x. That's alright, because our equation that we've got is x equals 0. We can think of that as x being a function of y. So this time it's the first term in the integral that we change to deal with the change of variable. So we take 2x plus y, and this time we multiply it by dx by dy, and that means we've got an integral with respect to y. And the second term we can leave unchanged. We'll now go back and put in the values for y and for x and dx by dy. So we're going from 1 to 0, and I'm noticing a little error up there. I've got a 1 where I mean a 0. And what we've got here is x equals 0, so we're just going to get y, but dx by dy is 0 anyway, so we've got 0 for that term, so we can forget it, 0. And for the second term, again we've got x equals 0, but here we've got minus y dy. So the integral in this case is going to be minus y squared over 2, and we're going from 1 to 0. Notice how careful we are with the direction of the limits. So in this case, with 1, we're going to get plus a half. Finally, to get the whole integral, we add them all up. So our integral along the curve C of f dot dr is going to be the first one we got, the first line, which gave us a quarter, plus the second line, which was minus a half, plus the third line, which was a half. So a quarter minus a half plus a half, giving the result a quarter. And that is the work done moving an object around the triangle subject to the vector field F.